Now, there is an interesting property of context-free languages that we will just give without a proof, which is that context-free languages, if a context-free language is intersected with a regular language, we get a context-free language. So if L1 is context-free and L2 is regular, L1 intersection L2 is context-free. So basically, if you intersect a context-free language with another context-free language, you will not necessarily get a context-free language. But if you intersect a context-free language with a regular language, you will necessarily get a context-free language. Okay? So, to just, for example, so let's give an example. Example of a context-free language. Example, L1 is the language NA of W equals MB of W. L2 and L3 is AN BN such that n is greater than or equal to 0. So what's L2? So now L1 intersected with L2 gives L3. Now what's the L2 that is regular? Give me a regular L2 that if intersected with L1 will give L3. Yes?
The language where all A's appear before.
Yeah, the language where all A's appear before, and that's regular, right? We can express that using a regular expression, which is what? Yeah, A star, B star. Or L of this regular expression. So A star, B star, what kind of language is this? This is clearly regular. This is a regular expression. So this is regular. This is context-free. And this is context-free. Of course, we have seen grammars for both. We have seen a grammar for this, and we have seen a grammar for this. And this is regular. So context-free intersected with regular gives context-free. So this is just an example. Of course, this is not a proof. This is just an example to show you what it means for a context-free language to give a context-free language if intersected with a regular language. Okay. Now, now given that AN, or let's call it, give it a name, L1 equals AN, BN, CN, n is greater than or equal to 0, is not context-free, show that L2 equals NA of W equals MB of W equals NC of W is not context-free. Now, given that this is not context-free, how do we show that this is not context-free? So the idea is in what we have covered, in the last two things that we have covered. The last two ideas that we have covered will give you the solution to this. So we will need to use this. It tells you that context-free intersected with regular gives context-free. So we can use the contrapositive of this. So now L2 equals, sorry, L1 equals L2 intersected with what? Same logic here. Same logic. So L2 intersected with what will give us L1?
A star, B star.
A star, B star, C star. Just generalize it. Just generalize this. So it's the language of A star. It's not a good star. B star, C star. Okay. Okay. So L1 is not context free. L2 is to be determined. And this is clearly what? Regular. So something intersected with regular is giving non-context free. Can this something be context free? If L2 were context free, then this would contradict this theorem that we gave without a proof. Okay, so then because, well, or you can also, you can argue you can use the contrapositive, right? Because this L1, L2 and intersected with a regular language is context free. Context free intersected with regular gives context free. So if you get non-context free, then either this is not context free or this is not regular. But we know that this is regular, so this cannot be context free. So because okay, or we can say L2, if L2 were context free, the theorem above would imply that L1 is context free, but it's not. Then L2 cannot be context free. So you have a theorem that tells you that context free intersected with regular must give context free. And you have this intersection, this language intersected with regular, giving you a language that is not context free. So this cannot be context free, because if it were context free, it must give a context free. The intersection must be context free. But we know that the intersection is not. Therefore, this cannot be context free. Okay. Okay, so now let's take another example. So let's see if someone can figure this out. Okay, show that L equals AN, BN, N is greater than or equal to 0, and N is not equal to 100, is context free. How do we show that, using all what we have studied, that this language is context free? Using that theorem, that context free intersected with regular is context free. So L equals something intersected with something context-free intersected with something regular. So what do you think the context-free one should be? About AN, BN. So L is going to be L1 intersected with what? The language that has, the string A100, B100. Is it the intersection? So if this is, if this is L2, let L2 equal A100, B100. Then L equals L1 intersected with L2. Is that right? It's intersected with a complement. Right? So L1 is the intersection, L is the intersection of L1 and the complement of L2. But, we know that this is context-free. This is context-free. And this is what? Why is L2 regular? Why is L2 regular? It has only one string in it. So the regular expression for it is itself. It's just one string. We said previously that any language with a finite number of strings is regular, because the regular string is just the union of the strings in that language. And this is even simpler. This has a single string in it. So this is certainly regular. So L2 is regular. And the complement of L2 is regular. Why? Because regular languages are closed under complementation, unlike context-free languages. Are closed under complementation. So this is context-free and this is regular. So the theorem tells us that what? Then L must be regular by that theorem. L must be context-free, sorry. L must be context-free. So this proves that L is context-free. So this is a proof, but it doesn't show the actual grammar. In fact, an easier way of, not an easier, a more constructive way of proving this is giving an actual grammar for language L. So can you come up with a grammar for L? That was an exam question, by the way, sometime in the past. So can you come up with a grammar for language L? Yes?
Didn't you say earlier, though, that context-free languages can't be closed under complementation?
Right.
But can't we just close it with complementation?
No, regular. Regular languages are closed under complementation, not context-free languages.
Oh.
This is regular. This is not context-free.
Oh.
Okay. Now, who can come up with a grammar for this? So this could be a question on your test. I gave this in a test one time. So can you come up with a grammar for this language? So basically AN, BN, but you have to come up with a way to exclude this. How can you come up with a way to exclude this? Now this is the problem solving skills. How can you exclude this? Like when you have a gap, right? It's like, okay, I can give you a hint. So it's like you have, A, you have epsilon, you have AB, you have AA, BB, you have all the way to A99, B99, then you skip A100, then you go to A101, B101, A102, B102, and so forth. So what's a good way of skipping this. So I have a gap here. Yes?
A really bad way is you just have like the ASP, but it goes to S1, and then when you go to S100, you don't have an ASP.
I don't see how this will work. I don't think this is going to work. Okay. Again, always, a key idea in designing grammars, try to analyze it into two different languages. This is the union of two languages, right? This is one language before the gap and the language after the gap. So write a grammar for what's before the gap and the grammar for what's after the gap. Then you skip this gap, right? So how can we do this? So let's try to do this. So S is either S1 or S2. Now S1 is going to give us the language before the gap. S2 is going to give us the language after the gap. So how do we express this? S1 is, how many strings do we have? We have a finite number of strings. So you just list them. So this is just epsilon or AB or AABB all the way to A99, B99. So, okay. Are these valid? These are terminals, right? So this is a valid production. Of course, in order to be really valid, you have to actually put all 100 productions. But here, we are accepting this for now because we don't want to write 100 strings. We know what they are. Okay. Now, what should the other one be? S2. AS2B or epsilon? Of course not. Then this is going to generate everything. It's going to generate everything. We only wanted to generate this. So that should be easy at this point. How do we make it generate this? Starting from A101. That's easier. The solution is simpler. How do you make it start from here? So when you put epsilon, you start from epsilon. I wanted to start from this, not from epsilon. So I just put A101, B101. Then it will start from A101, B101. Right? And then you can add as many A's and B's as you want. Does anyone have a doubt?
Do we need to have an epsilon there so it can end?
Why does it have to be an epsilon? No, we don't want an epsilon. If you put an epsilon, then you will get all the string and you will not skip this. The whole point is to skip this. The epsilon will just generate this language. Okay, so how do you derive? So S2 is AS2B, or you can substitute for S2 A101, B101. So what does this generate? It generates A102, B102. This is the string. So there is no way that you can generate a string with fewer than 101 A's. Okay, does anyone have a question about this? So basically we're trying to skip this gap. So we divide it into two languages. One language that generates this finite number of strings, and one grammar that generates this finite number of strings, which is always trivial. It's always trivial to generate a finite number of strings. You just list them. That's it. So this is regular. And then the language that generates the strings that start from at least 101 A's followed by 101 B's, then you can add as many as you want. Yes?
But can you go with S2 A, S2 B? Can you do that just like 99 or 200 times?
What's that?
Can you do S2 100 times to get that string that you don't want? A, S2 B? Can you do that 100 times? And you...
How?
There's no epsilon in
How can you do it? This is the minimum. This is like the minimum. You can't have less than 101. This is your minimum. So this starts here and goes up. There is no way for this to generate fewer than 101. And this can generate up to 99 only. Okay. Any further questions?